Increasingly, the startups that we hear about, those that are changing the world, those that are building solutions around technologies like robotics, like artificial intelligence, like advanced materials, like blockchain, like quantum, these technologies are increasingly pushing the limits. These technologies allow us to reshape our world, re-engineer our planet, and better understand the universe around us. And although you might think that these technologies are so complex, so intensive to develop, that they are only accessible to huge companies like Google's, like IBM's, actually increasingly the opposite is true. Increasingly, it's a small group of agile startup teams are the ones driving these ideas forward. These technologies that they are working on are disrupting these larger, more established groups in the same way that the invention of the engine, the steam engine, and automation changed how we work during the Industrial Revolution. I talked in a video previously about a startup with a quantum-powered technology that can search for gas leaks with incredible sensitivity and is disrupting an entire industry worth billions of dollars. But what else can they do? Some of the companies that I've worked with are teaching robots how to smell blood-borne diseases, kind of the same way that you can train a dog to smell a disease. Some are building paintball-like systems that allow you to paint on a molecular level individual cancer cells so that your cancer medication only attacks bad cells, not healthy cells. Some are re-engineering how we produce food to improve how well plants photosynthesize at the molecular level. These companies, these all fall into this big, broad category of deep tech. And now, to kind of better elucidate what that actually means, tech companies come in two flavors, slightly rudely called shallow tech and deep tech. The term refers to basically how difficult they are to engineer to actually get to market. What do I mean when I talk about a shallow tech idea? A shallow tech idea to me is something that is maybe still grounded in technology, maybe grounded probably in coding, in software, that sort of kind of sphere of knowledge, but arguably isn't too difficult to deliver at the end of the day. Typically, these sorts of things are very much those that require a good, strong cup of coffee, a fast laptop, and a good internet connection. By comparison, a deep tech idea is both technologically very difficult to deliver and arguably very difficult because the technology is so early to understand exactly what market problem it may solve. So there is both market risk and technology risk associated with these sorts of things. But why do we care about deep tech ideas? Deep tech ideas are the ones that are solving these real big global problems. I think all of the things that we are worried about at the moment, global warming, pandemics occurring, all of these things, typically it's not going to be a software company that solves these problems for you. If we look at the NHS app, I think we can all agree that probably a software solution at best is going to be pretty dodgy. What these solutions will come from are our deepening understanding of science. The frontier of that is going to hopefully progress at a time, at a rate that means that we can solve things faster than they kill us. To put it all in kind of rosy perspective. Deep tech ideas are important because they tackle the big challenges. Here's an idea that I came up with to better understand deep tech and start to differentiate it from things that I would otherwise call shallow tech. Across two different axes, I think about two sorts of criteria. Number one is time till the market is actually ready for this idea. Time till it can emotionally get over the fact that this is a new scary concept and wholeheartedly embrace it. That I plot typically across the x-axis. On the other axis, I think about ease of access into the marketplace. Is it an idea that you could cobble together in a few hours? Fantastic, scores really high, probably shallow tech. Is it something that you require a team of scientists to work on for about 10 years until it looks like it's remotely ready, as long as the stars are perfectly aligned and you all do the appropriate morning ritual that day? It's probably deep tech. As a consequence, when you start to look at ideas across these two axes, you start to understand how things fall. If you're building something like an app, probably that's reasonably straightforward to produce. Probably the market is reasonably ready to adopt it. Most apps are developed after you notice a problem in the world and you try and solve it with a software solution. If, however, you're thinking about building a quantum computer, the challenge is much, much, much greater. And arguably there are some market applications, but I would also say that we're still trying to work out exactly why a quantum computer is actually useful and what problems are most tractable for us to solve with them. To find ourselves somewhere in the middle, imagine if we were working on a technology that we thought maybe could help us treat diabetes. Imagine if we had developed a smart insulin. Well, the challenge, again, incredibly difficult, but the market much readier to adopt this sort of technology. Or maybe a counterexample. Yeah, soon maybe we will have the ability to take tourist trips into space, but when will the marketplace actually be completely okay with this as an idea? Well, one, it needs to have enough people that have enough money to take this sort of a trip, and two, it needs to probably have a wave of a few people at least that are particularly brave to prove that the thing isn't going to blow up as it launches or as it lands at least a few times, till the rest of humanity maybe is happy to take this idea as something that is now viable. So you might be asking, how do I actually get involved in this next wave of innovation ideas? I would say the best thing you can do, honestly, is do a PhD. Increasingly, a PhD is not for going into academia. Increasingly, a PhD is for touching forefront of scientific and technological understanding and then doing something interesting with it. And a PhD is actually, it's a hard ticket to earn, but it's a ticket to sit at the front seat, to see exactly what we are absolutely best at across different sectors of expertise, and then to see if there's something interesting in the real world that you can apply these things to. And why do I think it works that way? I think it works that way because it's much easier, in my opinion, to teach someone with a PhD in quantum mechanics a little bit about business, enough where they can start to spot and start opportunities, than it is to teach someone that has a wealth of business experience enough about quantum mechanics that they can actually do anything useful with it. If we are active encouraging this sort of mentality and taking ideas out the door in this way and empowering the scientists themselves to actually get these things started, if we do this, then the future belongs to scientists.